Hello everyone, welcome back to this new video. In this video, we will going to learn about Struct and Enum. So let's first understand like what is data modeling. So if you are coming from a Java background, so now let's assume like in Java when we need to do when we need to prepare our functional requirements, and when at that time we define our data modeling. Data modeling means like we will going to define our applications entities in a code ways. For example, if our applications need to deal with the products, then we will going to define a product class, and we will going to have all the required field for representing our particular product. And in case of order, we will going to have a order class, and we will going to follow the similar structure. But now let's come to this Rust. So in Rust, how we will going to define the data modeling. So now let's understand structure. So in a Rust, we will going to have struct and enum. So in functional programming, there is a concept of algebraic data types. So algebraic data types is like we can have data types that can support like a generic type. So for example, if you see in Haskell, so in Haskell, if I need to define a data type, I can define something like that, data users, and I will going to have a user constructors, and here I can define like this will going to have ID and like this is type of num, and after that I can define a name, and it will going to be type of a string or text, whatever it is. Okay, and when I need to also I want some out of the box functionality. For example, if I going to print this users on some interface, basically I want to convert this users in a to string. If you compare from Java, so we used to have deriving. So deriving is like implementing the existing a type class. So here I can define like I want to derive this show. So show is a type class which will going to deal with related to how to show that particular data type. And we have eq class. So eq class will going to deal with how we will going to compare to object of this users data type class. So likewise, we will going to have a ORD order for comparing to, for comparing two users, which is greater and which is less than. That we can use in while ordering that list of users. Something like that we have something in a pure functional programming language like in Haskell. The similar thing if you want to have in Java. So in Java, we need to define a class user, and in latest Java, like you can have a record also. So record user, and here we will going to define a like int. We will going to have a ID, and we will going to have a name. And if you need, this is how you can have a canonical constructor for creating a user objects. And if you need some behavior, then you can define your let me put yes. So if you want to have if you want to provide some behavior to the user class, you can have methods likewise. So if we see the same structures, then how we will going to deal with data modeling in Rust. So Rust has the concept of a struct. So if you are coming from a C and C++, we already learned during our college time, so we know about the struct. So struct is a way Rust is following for creating data. So when you want to create a custom type of a custom types, then you can use the struct. So for example, let's define struct user. So inside the user, I want to have ID which is type of I32 or signed integer 32. I want to have a name which is type of a string, and here let's have a email, something like that. So this is how we can create our data modeling for the users. For example, I also want to have a product. So here I can define like a ID, and it will going to be like a 64 bit, and after that I can define like a product name, and here I can define like a product name is type of a string, something like that I can define. and I can have like a mapping of users to the product, or also like a we can have here like just 1 minute. Okay, let's define order. It's up to us like how we want to model our data. So there is not like a very much difficult. I hope you are following. I just straightforward writing the structures define instead of like explaining, because we will going to learn by doing. So here like this is how you can define the structure. After that you need to define name of your entity, and after that you need to define what type of a data you want to carry corresponding to this entity. So in a similar way, for the order I want to have some id type of 64 or something integers, and I also here wants to define like a users, like a user. It will going to connect to users, and after that I want to define a product, and here it will going to have a product. And likewise we can define our entities. So now let's come to the point, like this is how we can define we can define our entities. So now how we will going to create the objects. So now let's create the objects for user is independent, so we will going to define a user, and here you need to define user, and after that you need to open the curly brackets, and here you need to define for the id. So id we will going to have 64, and after that we have a name, and for creating a name we have from. By using this we can define uh, string literals, and by using string literals we can it will going to create the string type. So product, sorry, users, let's have John, and after that what we have in users email. So strings and this, and the from previous lectures we already learned about ownership and borrowing, so you already know that this id will going to have a copy trait, and it is all it will going to store on the stacks, and name and email is does not implements the copy trait, and it will going to store on the heap. So we know that like all the objects which is storing on the heap, those store when we going to do the assignment operations, so those operation will going to invoke the move operation instead of the copy. So I hope it's clear for you. Still if you have some confusion or something, then I really encourage you to please watch the previous video. So this is how we can create users, and here let's create a product also. So product, it will going to have id 56, and after that we have a name iPhone 15. So now let's define order. So let's define order. So inside order we will going to have order id, and after that we need to define here user. So let's use this user. So for now just forget about borrowing and ownership concept. So we will going to discuss this in detail. Like here we are assigning this users to this user inside order, then what will going to happen to this user? Is this reference will going to mark as a invalid or not? So I really encourage you pause this video and just think about it. It will going to be marked as invalid or not. So now let's define this product. So here this is how we can define our order. So now let's come to this point. So we want to print this order. So now let's print, and here let's print this orders and try to run this. So here let's cargo run. So here we will going to see it is saying order cannot be formatted with a default formatter. So help the trait, this is something trait display is not implemented for order. So if we implement this order, this display trait to our struct order, then we will able to use something like that, this operators. And yes, and also if you want to read more about this error, so now we can run this and let's see. Okay, so there is a concept of deriving. So out of the box, like if when we going to display this order, so basically it does not know like how we will going to print this order. So there is a inbuilt trait like already like a debug, so we just need to derive our custom type from that debug. So it will going to print that print our order data type. So how we will going to derive, so how we will going to derive, so here we need to put this something like that, and about this in very much detail we will going to discuss. So for now just ignore this. So like if you remember in a Haskell, when we define a data type, after that we have a derive, so eq order something like that. So here we will going to derive something like that. So here we are deriving this, so we also need to derive our users and product, because we are using both in our order. So now let's run this again. So this time we will going to see our data. So now if you see we have order, and this is all like if you see this formatting, this everything is coming from these derive, we have derive. So now here if you see, in moving forward we will going to implement our own, and we will going to learn very much in detail. So please ignore for all these things. Just you can assume like in Java, when we define any user class, we have a toString. So this is some kind of a toString which will going to be implemented by default when we derived. So in a similar way we can derive other type classes also, like a EQ, partial EQ, something like that. I will going to explain moving forward. So here if you see, this is how it will going to be displayed. So creating a struct and modeling, this is how we can model our entities and our functional requirement like this. And this is how we can create the objects of type of a struct. And this is how we can create order which is also containing other struct type. So now if you see, we are using this users and this product. So it is displaying like three dotted. If you hover here, it is saying like shorthand structure initialization. Okay, so basically it's saying like we don't need to define key name and value name if both are completely same. And one more things also, now let's try to use this user. Let's see, are we able to use this user, or this value is moved inside the order and this is marked as invalid. So now let's see. Yeah, so now if you see this, so it is saying borrow of move value users. So this borrow operation is already happens for this user here. So when we going to assign this user, so basically the old reference of this user will going to be marked as invalid. So here if you see, you can see like it's displaying move occur because of user has type a user which does not implement copy trait. Okay, so what does it like copy trait? So here let's use this clone and copy trait. Copy trait cannot be implemented for this type. This field does not implement. Okay, this field does not implement copy trait. Okay, it's saying like a for name it does not implement copy trait, so we cannot implement copy trait. Okay, we will see about these things later. When I will going to learn more about in detail, I will explain these things in detail. So for now we understand like when we're going to do the assignment like this, it will going to move the values and old reference will going to be marked as invalid. So I hope this clear for you. So now let's move further to the enum. Okay, before moving to enum, so now let's understand. So just assume in a Java, like when we going to create any class, so for a user, so for providing a behavior, we can define a function. So what about this struct type? If we want to have some behavior corresponding to order, then how we can add that behavior to our order struct type? So for that we can have IMPL. So we can define IMPL order for our order, and here we can define a function. So these function will going to be related to this order class. So now let's instead of order, let's pick first user, because user does not contain any complex field. So okay, so here we will going to have some toString function. So in this function we want to access the user's data. So we have something like a shelf. We can define something self, and here it will going to be defined something like that. So we have a shorthand for this. Self is like for a users. So here we are borrowing the users data, we are not owning. So uh, this is how we can define. So instead of this, so there is a shorthand, something like that. We can define shorthand, and it will going to return strings. And here we will going to create a strings dot from, sorry, dot from, and here we can create the string. So id equals to this, and name equals to this, and email equals to this. And here we can access our IDs, email and name by using this self. So here if you see, we have ID, we have a name, and we have a email. Oh, sorry, my mistake. So instead of string, we can use format. Yeah. So this is how this format will also going to return a string. So this will going to format this everything. Like this is how we can define our template. It will going to create the string. So here we have created strings. We have created two string functions, and this is related to this users. So for example, so now let's do one thing. Now let's create another user1, and I want to print this user1 slash. So here let's define this, and we can have a user1 dot toString. So now you can see on this user we have this toString function. So basically we are calling this toString on this user1. So this user1 will going to be set as a self here. So this self is behind the scenes, something is like that self, and here we are borrowing this user data like this. We are not taking the ownership. So after using this toString, that user1 reference will going to be still valid. So the shorthand for this defining something like that is this. So this is how we define. So now let's run this and see. So now if you see, this is how it will going to be work. In a similar way, for creating new users, you can define some function, something like that, fn new, and this functions will going to be return a shelf type, and this shelf type will going to be denoted the user. So it's equivalent to defining something like that. So here you can create a shelf type, and here you can define a id equals to 12, sorry, and name we can define with start to string, and here we can define email start to string. So this is how we can create a new. So when you want to create a new user, so instead of defining something like that, you can define a user and new. And if you want to pass some data to this new function, here you can define, and those arguments you need to define here. It's a very straightforward. For example, so I want to pass this name as Vikas, and also I want to pass this email. So inside the new, I can have a name is strings, and email is also type of a string. So now let's remove this. We can have directly something like that, and here we need to call toString for creating this string literal to the string type. So here we will going to have user1. So now let's run this and let's see. So now if you see, it's working as expected. So now we have learned like how we can create a custom data type, and also we have learned how we can attach some functionality behavior to our data type. So now let's move further. So we will going to see how to create the enum. So now let's define enum. For defining the enum, you can use the enum, and let's define enum maybe. So this is some enum, and this enum can have some value like a constructor which will going to construct of this data type. So here I want to have a one constructor just, and I want to have a constructor nothing. So this is like a enum which we have in Haskell. Like here we have a optional option, and we in a Haskell we have maybe similar similar to option. So now if you see, this is some type of enum which we have defined. So when we want to create the enum, so now let's define let maybe. So if I want to define maybe, and here I can define something like that. So it's a very similar like if you want to define a num, and you can define like a option. So sorry, this is how you can define options. So even I think you don't need to type you don't need to like option enum class name to access this value sum. You can also use directly. It is provided by Rust. So that's why you can use something like that, but in our case you cannot use this just something directly. So this is very interesting. Like if you see this option, this is type of enum which has two value, none and some. So now we will going to see. So now let's move here. So now if you see like when we want, this is how like we can define the enum. And if you want to have this just to carry some data, for now if you see our these data type is not carrying anything. So here I created just type, so it will going to create it maybe. And if I want to have nothing, it will again going to be type of a maybe. So this is two constructor. By using these two constructor we can create the value for maybe. And also we can do like a pattern matching on this a maybe. So we can do pattern match like match, and here we can define maybe, and it can be a two type like just. Here we can define if it is type of just, then here we will going to return it is just type constructor. And if it is type of nothing, then we will going to return nothing. So here let's tag this, sorry, let's get this value, and now let's print this value, print ln, and here we will going to print. Now let's run this. So now if you see, it will going to display nothing. So here we have defined nothing. So if we want to define something like that just, so now let's rerun, and it will going to define something like that. It is a just type. So this is how we can create enum. But here enum is very powerful. Like if you want to carry some data along with this just, then you can define something like that. I want to carry 32-bit signed integers. This is how you can define. So when we going to create just type, so here you need to define, you need to pass the data. So I want to have some data along with just constructor. So basically here I am saying maybe has a two constructor, nothing and just is carrying some data with itself. It's very cool, right? So this is how you can define, and here you can get this value also, something like that. And let's let's use this value. Let me take this and let's use format micro. Let's use this, and here let's pass this state. So now let's run this. So now here you can see it is just type which is carrying 12 value. So this is how you can define a data type. If you want to have this generic type, you can define this generic type, and here you can have a generic type of a value. And if you want to add some construct on generic type, then you can use a where clause. That will I will going to explain later point of a time in a very much detail. So like in here if you see, like we have a enum option, similar type of a enum we can also create. So here we can have maybe it will going to contain a just, and it will going to contain nothing. Okay, so here when we going to construct the value, it will going to refer the type of this generic type automatically. We also need to, we don't need to define here. So if I run this, it will going to work as expected. So if I pass something like that, it will going to change this to string literal, and if I run this, it will going to be again work as expected. So it is very good. So in string type you can also define some, let's remove this. Okay, let's define order type. Okay, in order type we will going to have general order, and along with general order I want to have some value. So this is how we can carry the value. So the main point of this value does not have any naming convention or anything like any name is does not want to this value. So if we want to have some name, then this is how we can define. So string, so here this name, and we can have another type premium, and here we can have a name again, and cost. It's just a very random, I am assigning anything, so just ignore these naming order type, it's not making sense. But now let's learn the concept. So you can define enum like this, and you can have some constructor which will going to construct like this. So this is very similar to structure. You can define structures, and you can define a struct here. So don't be confused with a structure is another name. So you can define a struct type, and you can use struct, or even you can define directly like this. And when you going to create this value, so order type, and here you can define order. So I want to have a general type of a order, and here I can define the name. So abc dot toString. So this is how I can define order type. So I when I want to do like a pattern matching on order type, so I can have something like that, match pattern match, and this order type has two type of order, like a general, and I can destructures even the value here, something like that. And I can use this values, name is name, and so I can define for a premium something like that, name and cost. And after that, let's format name is, sorry, name, and cost is cost, something like that. We can define okay. So now let's use this thing, let's make this simple. Let's use format, or maybe just a 1 minute, so it will going to be very confusing, something like that. Or the better way of using format this to using a format macro instead of creating complex something like that. But now let's learn. This is how I am hoping like you are understanding these things, because it's very similar to our we already learned about ownerships and borrowing concept. So here we want to just take the borrowing. We don't want to take ownership for creating this name string. So it's saying mismatch type expected this found string. Okay, so let's result. Okay, so what's happened to this? Cost dot it is expecting mismatch expected this. Okay, okay. So now let's print this. This is type of a result. So now let's run this. Yes, so here you can see we will going to have a name is ABC. So basically we have created general type, so this is how it is playing. If we create some premium type, let's create premium, and we will going to have a name and cost. So here now let's define a name, the cost or toString, and here let's define a cost. So now if we run this, it will going to display something like that. So this is how we can do pattern match. And one more thing also, if you don't want to use this cost, right, so you can have something like that. So basically you are saying we are just ignoring this. So now let's remove this to omit a remaining field. So use this expected field. Okay, so basically it's saying something like that. Yeah, so this is how like we can ignore the rest type. But like using underscore was like makes sense. I don't know like why they have implemented something like that. If we use a cost something like that, it's saying try ignoring this field cost colon underscore. Oh, okay, cost colon underscore something like that. Okay, this is how we can ignore. This is a little weird. So this should allow to use underscore directly like we used in Scala. So I hope it's clear for you. This is how we can define struct and enum. So I have covered like this is how we can explore enum something like that. And there is one more things also, we can have a unit type of a struct. So like a order item something like that if I want to define, so I can have a struct something like that also. So this is a unit type of a struct. So basically it is equivalent of this. So basically this concept is coming from like in Scala and other language we call this a unit. So like it doesn't return like anything, returning like a unit. Like in Java we have a void, here like a similar to this, like we have a unit. So I hope it's clear for you. So in next lectures we will going to learn the next concept. So if there is any questions related to structs or anything, please put a comment. And one more things also, I will consider new lectures for understanding how to design how to do like a data modeling by using this struct and enum, because data modeling having that intuition is very important. So I hope if you like this video, please do consider to subscribe and like. Thank you.